Toxicology and LD50 problems show up quite often in forensic labs. Toxicology deals with poisoning or exposure to harmful chemicals, and LD50 stands for lethal dose 50, or the amount of the chemical that kills 50% of those individuals exposed. So how do we go about solving these problems? Well, luckily, the solution to solving our toxicology problems is fairly straightforward. We will be given the mass of an individual, and in the United States, that's typically in pounds. So to do our calculations, we must first convert pounds to kilograms. We do this by using the conversion factor 1 kilogram equals 2.2 pounds. So we take the person's mass in pounds and divide it by 2.2 pounds. Now this is going to make the assumption that the LD50 of a rat would be the same as that of a human. Next, we're going to multiply by the LD50 for that substance. How do we know the LD50 of the substance? Well, we have charts. And so we look up the LD50 value for the substance that the individual has been exposed to. And finally, we're going to convert from milligrams, which are very small units, to grams. And we're going to do this so that our final answer would be grams of the chemical exposed versus kilograms of the individual. So let's look at some example problems on these next few slides. Here we have a toxicology problem. What is the estimated LD50 of sodium chloride for a 180-pound man? Well, first off, let's take 180 pounds and convert that to kilograms. Remember that 1 kilogram equals 2.2 pounds. So what we will do is we'll take the 180 pounds right here, and we're going to multiply it by 1 kilogram over 2.2 pounds. This lets us cancel out our pounds. In other words, we've taken the 180 and we've divided it by 2.2, and so we get the individual is 81.8 kilograms. Next, we need to look up the LD50 value of sodium chloride. This means that we need to look at a chart. Here we have a typical chart of some of the lethal dose values of various substances. Now notice I've underlined and highlighted sodium chloride, and it has an LD50 value of 3,000. So we have our LD50 value of sodium chloride as being 3,000 milligrams per kilogram from our previous chart. We will take our mass of our individual in kilograms, multiply it times our LD50 value. We will get an answer of 245,400. Now we need to get this out of milligrams per kilogram and into grams per kilogram. So we will take this number and we will divide it by 1,000. We will do this because 1 gram equals 1,000 milligrams. So here we have our number divided by 1,000. And so we get an LD50 for sodium chloride for a 180-pound person as being 245.4 grams per kilogram.